So situation here, okay, we need to do more past paper questions. So these are going to be mixed questions now, and most of them would be about entire equilibria. Okay, so remember equilibria in equilibria we did KW, or we did dissociation constant of weak acids, that's Ka. We did the whole pH thing. Then we did KSP, and the last thing that we did was KPC as well, partition coefficient. So I'm just going to do some more questions, uh, which will include everything. So the first, I mean, this one, he's saying, yeah, he's saying, write an expression for the solubility product, KSP. I said this worksheet is in the group as well, of AlF3, right? So what happens when AlF3 dissolves? The solid dissolves, and in a saturated solution, it will turn into ions. Aqueous ions. So your KSP expression would be for this one is the Al3 plus concentration times your F minus 1 concentration, and that's going to be cubed. Simply that's what your expression is. Now, so that's what your expression is, and that's the first part. And then he's asking calculate the numerical value for KSP. So you have to plug in values and you have to find what KSP is. Now, what they've given us is the solubility, the concentration of its saturated solution that's already given. That's 6.5 times 10 power minus 2. So that means I'm going to take this as x just to simplify my math. So this shows that x mole per dm cube dissolves in a saturated solution. So the amount of Al ions that will dissolve would be present, that's going to be x mole per dm cube. And the amount of F minus 1 ions, that will be 3x mole per dm cube. Okay, so remember this is x mole per dm cube. Now the next thing is, this is the amount that dissolves. So I'm going to plug this in. It's going to be x and times the concentration of minus 1 is 3x, and that's going to be cubed. And the whole thing will become what? It's 3 cubed is, I think, 3 squares is 9. 9. I said 9 times 3 would be 27. And it's going to become 27x4. Okay, that's going to become 27x4. And I'm going to plug in. Okay, just to simplify my math, I used x is equal to 6.5 times 10 power minus 2. So I'm going to plug that in, and that's going to be 27 times 6.5 exponent minus 2, and that's getting what? It's power 4. So just go do this on your calculator. What do you get? 6.5 e minus 2. Isaac, are you doing this? Hala? Ibrahim, calculator hai? Minus 2, that's okay, that's power 4. And then it's getting multiplied by 27.
4.82 times 10 to the power of negative 4.
10 power negative 4, right? And you have to give the unit as well. The unit for this would be, for this, the unit would be, so concentration into concentration cubed. So it's going to be concentration to the power 4. So our unit would be concentration to the power 4 mole per dm cubed to the power 4. So that's going to be minus 3 into 4, that's 12. Okay, that's what my answer would be. Okay, that's what KSP is. So we're just going to do some more questions. Beach, I will start with the new topic as well, transition metals. I said, let's do a KW question. Okay, remember we did all the equilibrium constants. I said, what was KW? KW was the water ionization product. It was when water ionized. Okay, and when it did ionize, it would produce 2 ions, H plus 1 and OH minus 1. And your KW was the product concentration divided by the reactant concentration, except that you don't write the write the reactant over here, because whenever you have water, water is in large excess and its concentration is considered to be constant. Okay, so that's your Kw expression. And it had a particular value at room temperature. At room temperature, it had a value that there was 1 times 10 power minus 7 mole per dm cube of H plus 1 ions, and there was 1 times 10 power minus 7 mole per dm cube of OH minus 1 ions. Okay, so your Kw had a value 1 times 10 power minus 7 into 1 times 10 power minus 7. That gave you 1 times 10 power minus 14, and that's moles squared. And dm minus 6. Concentration times concentration. Okay, so I'm deriving the expression again. So concentration times concentration, that's mole squared dm minus 6. But anyways, and this value was a constant. All equilibrium constants are constants, except when temperature changes. Because if temperature changes, all equilibrium constants are no longer going to be constant. So what is he asking? He's asking, calculate the H plus 1 concentration in pure water, right, under standard conditions. So we kind of, इसका पिछले से तो कोई ताल्लुक नहीं है, एक सेकंड नहीं. अच्छा, so we kind of already know what the concentration is, but I'm suspecting because it's a part of the question, I think he gave us the Kw value, and he did not tell us what the H plus 1 and OH ion concentrations were. But you should know that both ions will be present in the same concentration. Okay, if water ionizes, it will produce the same amount of H plus 1 and OH ions. So it will become X times X, that will become X squared, and that's 1 times 10 power minus 14. And if you underroot this, X would come out to be equal to 1 times 10 power minus 7. Okay, so I think in the question, they probably gave us the value of Kw. Achha, but in the next one, ये वाला तो clear है ना सारों, is this clear? तो वैसा है hala, is this clear what Kw is?
Yes.
Yes, sir.
Okay, so achha, now the next one. Remember, the temperature has changed. Whenever you change temperature, the Kw value will change, and that is exactly what he's asking. He's asking the value of Kw at 50. Now, Kw has the same exact expression, H plus 1 times OH ions. And water will ionize, so it will produce both ions in exactly the same quantity. 1 H plus 1, 1 OH ions. Now, the pH is given. You can remember what pH is. pH is the negative log of H plus 1. So the pH is given, that's negative log of the concentration of H positive ions. So okay, that's given, that's 6.64, right? And remember, I told you early on, okay, how do you go from pH? For those maybe you've missed some early classes, so I'll just briefly tell you that what pH is, it expresses values in the powers of 10. So for example, if you have 10 power minus 3 mole per dm cube, the concentration of H plus ions, pH will come out to be 3. But if you take the negative log, it's going to come out to be 3. Ika, I told you that you take log because log expresses the numbers in whole numbers. It's easier to make graphs. But it's a lot more difficult to plot 10 power minus 3, but it's a lot easier to plot 3. So that's why scientists, whenever they're making graphs, they really like log. What negative sign is that because I mean the reason there's a negative sign is that that instead of making a graph of minus 3, which it should have been minus 3, they just multiplied it with minus 1, so they get rid of the minus sign. So anyways, so the reverse is if they give you 3, that means the actual concentration is 10 power minus 3. So if they give you 6.64, that means the actual concentration of H plus 1 is 10 to the power minus 6.64. Okay, so that's mole per dm cube. So whenever you see pH, 6.4 or 3 or something, it just means it's 10 power minus 3. If it's 6.64, that means it's 10 to the power minus 6.64. So what they've given us is that the H plus 1 concentration over here is 10 to the power minus 6.64 mole per dm cube. Now we know the OH concentration will be exactly the same. Because it is pure water. You can remember it's written over here, it is pure water. So the other ion will also have exactly the same concentration, that's 10 power minus 6.64 mole per dm cube. So we just need to solve this. So it's 10 power minus 6.64 times 10 power minus 6.64. Yeah, what do we get? Yeah, I can see anyone.
Yeah, 5.25 times 10 to the power minus 14
So 5.25
times 10 to the power minus 14.
you get mole squared dm minus minus 3 minus 6. You get concentration times concentration. So anyways, what has happened is, under normal conditions, the KW had a very specific value, which was 1 times 10 power minus 14. Okay, so, but if you increase the temperature to 50, the water will ionize more. There'll be more collisions. There'll be more H plus 1 and OH ions being produced. Okay, if you take it to a higher temperature. So you'll have more ions, and therefore your KW value will also be slightly lower, slightly higher. It's 1 times 10 power minus 14. This is 5.25 times 10 power minus 14. So it's bigger in size. So that means the equilibrium is slightly shifting forwards. Okay, you increase the temperature and your equilibrium has moved slightly forward. Okay, you clear? Is this question clear about KW? Directly clear. Ibrahim clear Hara.
Yes, sir.
So we did this one.
Yes, sir.
As a KP would go to the thing. I mean, you might get questions on KP as well. We did a lot of questions. I'm just one last time. Let's do KSP दोबारा आगे एक second. This is normal KC. KSP. Maybe we've already done KSP questions. 1 second. See, we did a lot of questions in class already. Let's do this one. ठीक है, चलो ये वाला. About making graphs. This is about K. So he says that sulfuric acid is ionizing. And there's an organic base which is so sulfuric acid is ionizing, and there's an organic base, guanidine, contains carbon and whatever, and so it's a base. It accepts what H plus 1 ions. So it's a base by definition. Where B represents the molecule of guanidine. When 25 cm3 sulfuric acid was titrated against, so remember in the container below, you have sulfuric acid. And you have the volume, which is 25 cm3. So 25 cm3 sulfuric acid was titrated against a solution of guanidine. So you're pouring guanidine from the top. And guanidine is your base, which is B. So, I mean, that's your base. And they've given us the titration curve for that. Now I exactly know what volume of guanidine is completely neutralizing. For the pH 7, this is where pH 7 is happening, right? Hopefully that's a straight line. So I exactly know that this is the equivalence point. I mean, equivalence point is the point where exactly the right amount of moles are added, right? So the volume of guanidine, I can figure this one out, that the acid has been neutralized. I think that's 34 cm3, right? So the volume is 34 cm cube. So use this curve to answer the following questions. Is guanidine a weak base or a strong base? So remember, that's why I said, what does the curve suggest? Is it a weak base or is it a strong base? Yo, anyone mess up? Is it a ether? This is the point where you had acid, and then the acid got completely used up because you're adding guanidine from the top. It's going to get completely neutralized, and then you add excess guanidine, and the pH goes up. Yeah, but what is the pH? It's like very close to 14 or almost 14. So it's a strong base. So you don't need much of an explanation. It's a strong base. The pH is close to 14. So I guess that's it. Then he says the pH at the start of the titration, right, when you had sulfuric acid in your flask. So right at the start of the titration, he told us that the pH is 0.7. Okay, so this pH over here is 0.7. Achha, I just told you, okay, how do you go back? If pH is 0.7, that means your H plus 1 concentration will be 10 to the power minus 0.7. You can solve this. Okay, what is 10 power minus x y? Minus 0.7 minus 0.7. So that's, I think that's approximately 0.2 mole per dm cube. So that's approximately 0.2 mole per dm cube. And hence, calculate the concentration of sulfuric acid. Now, sulfuric acid, I mean, the first thing you need to look at is that, did he mention that it doesn't ionize completely? Well, I'm going to assume that he is saying that in the question. Okay, but did he mention it anywhere? But he did say that it's a strong dibasic acid. So which ionizes in solution as follows. So we're assuming that it is completely ionizing. And that's probably the only way we can solve this. So this is 0.2 mole per dm cube. So sulfuric acid would be, according to the ratio, it will be 0.1 mole per dm cube. Okay, so that's what sulfuric acid is. At the start, pH was given 0.7. I figured out H plus 1 and then I figured out sulfuric acid. Now we're seeing calculate the concentration of guanidine in the solution. Now this would require, it's probably going to be a moles question because first thing is I need to figure out in what ratio are sulfuric acid and guanidine reacting in. Because if I don't know what the ratio is, that would make it kind of hard to difficult to figure out the concentration. So now look at the two equations over here. Sulfuric acid produces how many H plus 1 ions? It produces 2 H plus 1 ions. While guanidine accepts only 1 H plus 1 ions. So that kind of means when you're going to balance this equation, there's going to be 2 guanidines. Okay, because it would, if that is producing 2 H plus 1 ions, then the base will have to accept 2 H plus 1 ions. So that means the ratio between sulfuric acid and this base guanidine over here, that's going to be 1:2. ठीक है? ये clear है? ये बात समझ आई? Ishaq, is this clear? Hala, Ibrahim, Professor,
Yes.
Qasim. So the ratio of the acid with the base is going to be 1:2. So that is the first thing I need to know. So it's going to be 1 sulfuric acid reacting with two quantities. So now sulfuric acid, I know I have the volume, which is 25 cm3, which was given before. And did they give us the, I figured out the concentration of sulfuric acid. That's 0.1. So I can figure out the moles. Moles ke hote, that's concentration times volume, so that's 25. Or it's 20, you just multiply the two. So it's going to be 2.5 times 10 power minus 3. Concentration times volume, 25 times 0.1, but divided by 1000. So I have the moles, and the moles of guanidine will be double this. So that's going to give me 5.0 times 10 to the power minus 3. Yeah, that's going to be double. And what do we need to find? We need to find the concentration. So just to rearrange, concentration is moles per unit volume. So we have the moles, that's 5 times 10 power minus 3. And the volume we already know about guanidine. Okay, this was the equivalence point. And it was 34 cm cube. So in dm cube, it's going to be 0.034 dm cube. 34 divided by 1000. Yeah, I think it's the same. What do you get for this?
So 0.1471.
So 147 plus mole per dm cube, right? And the next one is, okay, they are saying that the guanidine solution contained, I said it was more like a moles question rather than a pH. There was some part with pH, but otherwise, I mean, there's only one tiny section about pH where you had to find the sulfuric acid concentration. Then he says guanidine solution contained 8.68 grams of the base per dm cube. So calculate the MR. So we've got gram per dm cube and we've got mole per dm cube. So that's easy. Okay. You have the moles. You also have the mass per dm cube. So the MR would be the mass divided by the moles. Moles is mass divided by MR. Yeah. So it's going to be 8.68 divided by 0.147. Which is what? क्या है इसका क्या है आंसर? Ibrahim, Isaac, Hala, Rumesa.
59.05.
9 point. Let's make it one. These hidden figures. So that's what our answer is. I think this one is it's just a simple. I'm going to skip this one. It's simple pose. Buffer solution. Okay, we got a question on buffer solution. What was a buffer? Explain what is meant by the term buffer. So buffer was that it's a solution that is going to resist a change of pH. That resists change in pH. Simple definition, a change in pH. When a small amount of acid or alkali is added. Or alkali is added. It's basically going to neutralize both. And how is that? So that is it. Okay, that's what the definition is. It's just going to resist a change in pH when a small amount of acid or alkali is added. And how is a buffer formed? A buffer is formed when you have a weak acid and you also have its conjugate base as well. Okay, that's how a buffer is formed. So basically, a buffer solution is going to be, let's say you've got a container. So the buffer solution is going to have the weak acid, H2PO4 minus 1 ions. And it's also going to have the conjugate base, which is HPO4 minus 2. Okay, and remember, if you just add a weak acid normally doesn't ionize a lot. So a weak acid, only a weak acid, will not be a buffer because the amount of conjugate base produced will be very, very less. I mean, the weak acid doesn't really like to ionize. So this has to be added from outside, normally in the form of the salt. Again, this is exactly what he's doing. He's adding 2 salts. Okay, so one of them, I mean, this salt over here, NH2PO4, remember the sodium is kind of irrelevant. The sodium is just a spectator, and so this salt is producing, so this salt over here is producing that ion, and this other salt over here is producing this particular ion. So one of them is the weak acid, and the other one is the conjugate base. It's behaving as the conjugate base because in the reverse direction, it's going to accept H plus 1 ion. And in the forward direction, this is going to lose an H plus 1 ion. As anyways, you're being asked to calculate the pH of this buffer. So what is the pH of the buffer? How do you've been given Ka, dissociation constant. Dissociation constant is the equilibrium constant of an acid, a weak acid dissociating. So what is the expression? It's HPO4 minus 2 concentration, that's my product, times H plus 1 concentration divided by my weak acid concentration, which is H2PO4 minus 1. All I need to do is I need to plug in the values. The Ka value is given, that's 6.3 times 10 power minus 8. Okay, that's given over here. The HPO4 minus 2 concentration is given, and that's 0.1. Here, that's this one. HPO4 minus 2. Okay, remember, the Na is completely useless. Whenever you see Na anywhere, it's just a spectator ion. It's probably going to dissociate if you mix it in water, and it's going to just fly away. And that ion will be just floating around. Okay, so Na is completely pointless. I said, so I'm going to plug in the values. HPO4 minus 2 is 0.1. I don't know what H plus 1 is. And HPO4 minus 1 or H2PO4 minus 1 is this one. That's the weak acid. So that's 0.2. But here, you got to solve this. So I just need to multiply this by 2, I guess. That's H plus 1 concentration. And then I have to take the negative log of this to figure out pH. God, can somebody do this? What's the pH that we're getting? Six point three times 10 power minus 8, and then
6.9, I guess.
because that's what your pH is. I said, so that's your buffer solution question. And I say even if, because we've got a buffer solution question, if they had asked, how does this buffer act? I mean, write equations to show this buffer in action. So if I add H plus 1, remember, so if I add acid to it, so I'm just going to add equations like, because they normally do ask this question right after this. So how does it neutralize the acid? So if you add H plus 1 ions, then remember the conjugate base is the one that's going to accept it. In our case, the conjugate base is HPO4 minus 2. And this equilibrium is going to shift backwards, right? It's going to accept it and it's going to form H2PO4 minus 1. Okay, that's your equation. That is how the conjugate base is neutralizing the weak acid. As a vice versa, if you add base to it. like OH ions. Who's going to release the H plus one? Who's going to neutralize? The weak acid is the one that's going to neutralize it. The H2PO4 minus one is going to give it an H plus one. It's going to turn it into water, and it will turn itself into HPO4 minus two. Basically, the equilibrium is shifting forwards. Okay, you got to add this OH ion somewhere inside the equation. Okay, I mean it's shifting forward. If you add a base, the weak acid releases an H plus one, which neutralizes OH ions and turns into HPO4 minus two. So here, let's do skeleton. Calculate the expression for the K expression for methanoic acid. So I've got methanoic acid, it's going to dissociate. And it will produce an H plus one ion. So what's the K expression product concentration divided by? So it's going to be HCO minus one concentration. That's my products, H plus one. And divided by the weak acid. Because that's my expression. And use your expression to calculate the H plus one concentration. So we need to calculate. Now remember, we have the K value with us. So I'm going to use this expression. It's 1.77 times 10 power minus 4. I have the acid concentration. The methanoic acid concentration is, that's given over here. That's 0.05. What I don't have is this thing, the numerator. But remember, both of these ions will be produced in exactly the same amount. So that means so my product is going to be concentration times concentration divided by this concentration. Okay, so it's going to be x times x, that's going to be x squared. So I just need to solve this. And x is basically my H plus one concentration, and that's going to give me 0.5 times 1.77 times 10 power minus 4. And then I have to take the under root for the whole thing. Okay, so we'll do that. So and he's just asking, in the next part, he's asking for the pH as well. So, what is this? 0.5 times 1.77 exponent minus 4.
(9.41 times 10 to the power of negative 3).
Times 10 per negative 3? 47,
Yes.
9.41.
One second.
Take the pH as well. Take the negative log of this. What do you get? Because the next part is about pH.
Um, 2.03.
It's 2.03. And in part 3 is basically asking, calculate the percentage of methanoic acid that is ionized, right? So go back. How much methanoic acid did we have? We had 0.05 mole per dm cube. And what is the amount of H plus ions that are produced? That's 9.41 times 10 power minus 3 mole per dm cube, right? So you just have to calculate the percentage. So it's 9.41 times 10 power minus 3 out of 0.05 times 100. You'll get this. Like I said, 0.05. 18.8%. Yeah, that's the percentage that got ionized. Yeah, is this clear? Or I guess Baki, I think it's. I mean, we've done a lot of questions. I'm just going to briefly, बस ये नहीं करें. Baki, the worksheet is with you. We've done a lot of questions. Try and go through, try and complete this worksheet. ठीक है? Up now, what I'm going to do is I'm just going to give you a very short, brief introduction about The topic we're going to start, ठीक है, and that's अच्छा short ही होगा, एक second. So we're going to talk about. I remember in A levels, the inorganic chemistry part is you just have one topic, and that's transition metals. That's it. But there's although the problem is that they might ask questions on your AS inorganic, which happens, but at least the question is not focused on that. But maybe some tiny part on AS inorganic, but most of the question is going to be focused on your A level stuff. The problem is chemistry is all completely interconnected. So you still have to, even for that tiny part, you would still have to revise your AS inorganic. I'll share notes, AS inorganic notes. You can revise those on your own. I said now transition metals, there's I say it's not normally you get questions on transition metals that are very straightforward. Inorganic, there's not much of an understanding. So you mostly just have to remember the notes. There is some understanding for transition metals. There's actually an equilibrium constant as well that's going to be studied over here. Or transition metals, the basic summary is that what we're going to study is that you learned a few things in O levels, that they have high density. So you're going to learn now, okay, why do they have high density? You learned that they have high melting points. So you'll learn why do they have high melting points. They have 5 properties. They were colored compounds. They formed colored compounds. So over here you're going to learn that why do they form colored compounds, and what happens. मतलब उसकी पूरी detail वगैरह. फिर और क्या था? Variable oxidation states. You're going to learn about that. Catalysts. You're going to learn about that. ठीक है. But so we're going to discuss the same points that we studied in O levels, but in a lot more detail. ठीक है. So, लेकिन there's only one topic in inorganic, and that's it. So we just have to do this. So we'll start with this tomorrow then. ठीक है.